Have you ever wondered how close we are to building robots like the ones you see in Westworld? Let me introduce you to the Clone Robotics torso, the game-changing humanoid robot that's blurring the lines between science fiction and real life. This torso uses 910 hydraulic muscle fibers and has 164 degrees of freedom, which gives it lifelike strength and motion. It's even training to perform tasks with both muscles simultaneously, just like a human. Powered by advanced AI, it combines speed, precision, and natural dexterity. And the big vision? Clone isn't just building robots. They're working towards synthetic humans. So think realistic skin, lifelike hands, and natural interaction. Their ultimate goal is to solve real-world problems using robots that move like us. Exciting, right? So hey there guys, what's good? My name is Tino and welcome to Hello World, a brand new channel here on YouTube where we explore all of the new advancements happening in the world of AI and have a go at trying to build real world projects with them. Alright, so today we're going to be taking a look at Clone Robotics, who've just released an update to their humanoid robot, which looks absolutely incredible, and they've been drip feeding us updates for almost 5 years now, and I've been paying attention since the very beginning. So it's very exciting to see how far they've come and how complete this robot seems. So if you don't know them, Clone Robotics are a company based in Poland, and their whole goal is to build an android based as closely as possible to the human body. I first came across them when I was trying to build a 3D printed robot hand, and in my research at some point I was looking at biomimetic hands, basically robot hands that are designed based on the human skeletal structure. I ended up going with something a bit more simpler after seeing a kid build a hand using only a lollipop stick, cardboard, and a few servo motors. I've got plans to revisit this project, so if you want to see it, stay tuned. But anyway, in the journey to build a synthetic human clone, they started with the goal of making a biomimetic hand. It's probably one of the most complicated things that you could try to mimic. Even Elon Musk said this recently in a podcast, and he knows a few things about building robots. Their hand is designed to perform any manipulation task a human hand can, and the way they do it is completely different from any humanoid robot that you might have seen popping up on your timeline. Instead of using mechanical actuators, which is what you see in traditional robots, Clone have developed synthetic muscles, much like the ones you see in the human body. But these only run on electricity and water. They claim that these myofibers contract much faster than human skeletal fibers, offer the same strength, and are extremely lightweight. Over the years, human beings have adapted to the natural world by shaping their environments to their needs. And when you think about it, everything around us is designed specifically for us. So that's why many of these robotics companies are using that as a philosophy for designing these robots. It makes them instantly backwards compatible, so we don't have to redesign our world for them. The hand that Clone Robotics built after 8 years of research and development have faithful, opposable thumbs, which is arguably what separates humans from everything else, allowing us to manipulate objects with superior dexterity. So if you look at these examples, it moves exactly like a human does. The same range of motion and the same tendon contraction. You can see how far they've come in these early tests that they posted on YouTube. They start off with a hand doing simple motions, but gradually get more and more complex as the team figures out the control system to the myofibers, which work using a big hydraulic water pump. There is also this video showcasing the research that they're doing to eliminate the big hydraulic system with an artificial muscle that only needs 12 volts to contract. They're thinking of using this for human prosthetics or for future versions of the robot. So after the years of doing research and development into the human hand, they were able to move on to building the upper body, and they released this video a few months ago, showcasing the upper half without skin, moving like a zombie. To make this, they had to mimic the human muscular, nervous, and vascular system. The muscular system animates the skeleton using the myofibers we talked about. The synthetic muscles need to be super quick, really strong and lightweight, so that means reacting fast in less than 50 milliseconds. That's faster than the blink of an eye. They need to be flexible so that they can shrink by over 30% of the original length when it contracts. And obviously they need to be powerful. In this case, they need to be able to lift 1 kilogram of weight using just 3 grams of muscle fiber. Right now, Clone Robotics Myofiber is the only artificial muscle in the world that can combine all these features. It's lightweight, powerful, fast, and energy efficient. The skeletal system contains all the 206 bones of the human body. The joints are fully articulated with artificial ligaments and connective tissue, and things like the 4 joints that connect the shoulder blade, collarbone, and upper arm bone all move exactly as you would expect them to. The clone is designed to control itself by using visual feedback and 70 inertial sensors that provide joint level information on angles and velocities. All these sensors are controlled by the boards mounted along the vertebrate. They send lightning fast signals to and from a NVIDIA GPU that's running Cybernet, which is a foundation model specifically designed for clone. We haven't seen videos of it moving, as well as the actuated powered robots like Optimus and the Boston Dynamic Atlas. Maybe because orchestrating all of these pumps and vessels within the body is way more complex than telling a few servos to rotate. But if things keep moving the same way for this company, they're surely going to crack this code as well. And then what? I guess we'll have to wait around and find out.